Okay, so for the first couple review questions here, we're multiplying the bases. We're just going to add these exponents together. That'll go A, B, C, and D are the same way. So we have 3 to the 6th, then we have 2 to the 12th here, 5 to the 28th, and 5 cubed and S cubed over here. For E, we have 5 to the 4th power. The negative is out front, it's outside of the parentheses, so we just leave it alone. That becomes 625 minus, or with the negative on the outside there. Okay, over here on 5 to the 4th power, we end up with the negative on the inside of the parentheses, so as we do that, we get a -5 and a -5, they become positive. Another -5 becomes positive, and we get 625 as a positive. -5 to the 0 power, the negative's on the inside, so everything on the inside to the 0 power is always going to give us 1. And here we have -5 to the -4th power. And so it's the same problem that we had over on this side. We're going to do the same thing, except with the negative exponent, we end up in the denominator. On the bottom, combine like terms, we have same base, add the exponents, get to the 6th, same base, add the exponents, A to the 6th, same base, add the exponents, we get -6. Oh, we don't like that. We're going to flip it, make it 1 over y to the 6th. Here we have n to the -3. N to the -3 gives us n to the -6. Again, we want to flip it. Down here, we write all these guys out in expanded form. So 3 times 3 times 3 times 3 times 3. You keep going. You end up with 3 to the 12th, 5 to the 12th, 2 to the 28th, A to the 6th, G to the 12th, C to the 12th. Down here we have a power to a power. So now instead of adding, we want to multiply these two guys together. So 6 times 3 is going to give me 8 to the 18th. Okay, -4 times 5 is going to give me -20, or 2 to the 20th power underneath the 1 there. What pattern do we see when we raise a power to a power? You're going to multiply the exponents together. So power to a power, multiply the exponents together. Okay. Raising a power to a power, for every non-zero number, integers, we have a to the m times n. Here are some examples where you see that multiplication. And then if we have parentheses, we now want to distribute. Remember, we can only distribute as long as there's no addition or subtraction. If we have addition or subtraction, we're going to kill something. We don't want to do that. So we do want to distribute here. Down here, what do? We multiply, and then we have to add because we have the like bases. So you see the difference here. Multiply only. This is going to be multiply and then add like bases. So we get 1 over b to the 4th. Down here, we want to simply multiply, so we get a to the 28th. Here we get a to the -28th, or 1 over a to the 28th power. Simplify. Ooh, now we've got multiple steps. So we have to do to the -14th first. Then we add the exponents, because we have like bases, so we add the exponents after that, get -12th, 1 over 2 to the 12th. Here we've got a couple steps, so we have to multiply 4 times 2 gives us 8. Multiply 2 times 5 will give us 10. Power to a power means we multiply. Power to a power means we multiply. Put them together, we get a to the 18th. Over here we have 5 cubed, 5 to the 6th. Because they're like bases, we're going to add the exponents and get 5 to the 9th. Again, like bases are being multiplied, add the exponents. Very different looks in these problems. We have very different looks in these problems, so you've got to make sure that you see the different look. You don't just do something because you feel like you need to do it. Here we have 3 terms. They're all the same term, 7, 7, 7. So -3 plus 2 plus 6 gives us 7 to the 5th power. What's the difference between the two quick checks? These guys on top are power to a power. These guys on bottom are multiplying like bases. So we multiply here and we add exponents on this guy. Simplify the products raised to a power. A power raised to a power means we multiply the exponents. The same base, add the exponents. Okay, so we're going to go down. There's a bunch of simplification stuff that goes through here. Again, do the power to the power first. before you do any adding. Just like our normal multiplication, before we do addition stuff, we want to do these powers to powers first. Remember, on these powers, we want to distribute them to each term as we go through. So distribute to each term before you start combining like terms. And again here, distribute our 4 to the 2. You see I got 2 to the 4th power. Distribute my -2 through. Distribute. And even more distributing here. Ooh, one extra distribute. There we go. Once you've distributed, then you can go through and work this stuff. Using power to the power with scientific notation, skip that, you don't have to do it.